Hi, welcome to Tammy the Tutor. We are in CC3, lesson 1.2.2. Number 57, solve each of the following proportions. Okay, so you've got this wonderful proportion sitting here and you just need to solve for x. There's a couple of ways you can look at it. I like to first look, let me make it bigger. Before I try the cross multiplying, I just try to see if I can make it make sense as a very simple equivalent fraction first. It's like using that giant one. And so I start off by looking, I compare the two numbers across that they've given me. You see how up here I only have one they've given me. So find where they've given you both of them in a row. And you ask yourself, how do I get from 24 to 36? And that might be a little bit big of a number for you to just do mentally. So here's another trick. Come over here, look at 30 over 36. That can actually be reduced. And once it's reduced, I bet it'll be a number that we can easily find from a 24. So I'm looking at 30 over 36, and they definitely can both be divided by a 6. So 30 divided by 6 is 5. 36 divided by 6 is 6. Okay, so I'm going to get rid of this. Actually, let me make this closer. Okay, now, how do we get from 24 to 6? And it's division, but if you like it better, you can go from here to here. So how do you get from 6 to 4? Which means I'm multiplying this times 4 to get 24. So do the same to the top. 5 times 4 would be 20. So x is going to equal 20. Now let me go back and start over again. Let me show you another way. And I'm going to keep it with my 5 over 6 because smaller numbers just make it easier. And as long as it's equivalent, it doesn't matter. You'll still get the same answer. So here's the cross reducing or cross multiplying strategy. And this works every time, no matter what. But sometimes you can see it simply over here, so you can just quickly do mental math. So here, check it out. You want to go across and multiply. 6 times x is 6x. Set it equal to 5 times 24. So quickly figure that out. Okay. Now you have an algebra equation, very simple, and you can quickly solve that. So that's 20. Either way. Okay. B, I have 5 over 7 equals x over 3. Okay, I am thinking about my giant one, and I'm like, I don't know, 3 times what? It's 2 point something. So not a really friendly number that I will know how to do in my head. So I'm going to use the cross multiplying method. So go this way, 7 times x is 7x. Set it equal to 5 times 3 is 15. Divide both sides by 7, and x equals 15 sevenths. You can leave it like that, or 7 goes into 15 twice with 1 left over. Okay? Okay, C. If Joan read 75 pages in 4 hours, how long will it take her to read 250 pages? Okay, we have to set up our own proportion just like this. They have given us a word problem, and you just have to learn how to read them and turn it into this. This is actually one of the easiest things to do. And then once you've actually come up with this, now you know a couple of strategies to use to solve for x. So here's the deal. I have 1, 2, 3 numbers. They will always give you 3 numbers. And the point is that fourth one is an unknown and you're looking for it. So write down the first 2 numbers that you see in the exact order you see it as a fraction. I see 75 pages in 4 hours. And then they give you that third piece. You just have to decide, does it go on top or bottom? And this is really important. You can't just throw it wherever you want. It has to match the left side. So this is talking about 250 pages. Well, the 75 was talking about the pages. So it has to go on top. Okay? Now, once you have this, you can cross multiply like I've done before. 75 times x is 75x. 4 times 250 is 1,000. Divide both sides. Okay, let's come over here and see. 75 goes into 1,000. That's going to go once. 25 left over. Bring down your 0. I think 3. 3 times 5. 21, 22. 4 minus 2. Okay, and then, oh, guys, it's going to keep repeating. Okay, so I just willy-nilly added another 0 here. I can do that as long as I make this a decimal. Then you can bring down that 0, but that decimal needs to come straight up. So we're going to do 75 into 250 again, and it's going to be 3. And I can just tell you right now, it's just going to keep being 3. So basically, the answer to this is how long will it take her? 13.3 hours, or you could even turn that into a fraction, which is 1/3. Okay. Number 58. Mr. Wright was making a table to figure out how much it cost to send a certain number of regular letters through the mail. Use proportional reasoning to complete his table at right. Okay, so I love these ratio tables. I love proportions because everything is so consistent. As soon as you can figure out how they got from 10 to 4.5, whatever they're multiplying 10 by, you're going to use that number and you're going to multiply it all the way down. Okay. So you can either just ask yourself 10 times what is 4.5, and you can use a calculator. You can write it down and do math, but I love doing this with mental math as much as I can. And I assure you, you can do this more than you think you can. If you don't understand the powers of 10 very well, and that one's not ringing true with you, look at this one. I think about money when I'm talking about decimals. To me, I look at this and that's 90 cents. So I'm like, 2 times what is 90 cents? Well, 45 cents. So I already know I'm multiplying everything on the left times 45 hundredths to get the number on the right. So let's do 7. 7 times 0.45. 8. Okay. So this is 3.15. Oh, 1 times 0.45 would be 0.45. That's an easy one. Okay. 6.75. We have to divide this time because we're going backwards, right? In order to do division with decimals, guys, this divisor number on the outside of the bracket cannot have a decimal. So you need to turn this into a whole number. Really what you're doing is multiplying it times 100, but the quick shortcut way of thinking of it is make 2 hops to the right, and it's a whole number, but what you do to one side, you have to do to the other. So come make 2 hops to the right. So really now they're both just whole numbers. So let me rewrite it so it's not messy. And that was 675. So it's going to go in 1 time to this. Bring down your next number. And, oops, make that 45, 90, 35. It's going to maybe go in 5 times. Yeah. Okay, so that would be 15. So now we have to do 500 times 0.45. Add them up. So 225. Then we have another 1890 divided by 45. So I'm not going to put the decimal, guys, because in my mind I'm thinking, okay, I have to make 2 hops to the right, and I have to make 2 hops to the right with this one. So I'm just going to come delete this one. 45 goes into 189 4 times. Bring down the next number, and that's 2. Okay, so 42. So really easy. So you just have to find two numbers side by side that they've given you, and whichever one you choose, find the relationship, and it's easy. You could have just said 4.5 divided by 10 or 0.9 divided by 2, whichever one you want. "59. Kelly asks some of her classmates how many hours of sleep they get on school nights. Here are the results." Okay, copy the set of axes below and create a histogram for the data. Okay, so again, if we have a list of data, what is the very first thing you're going to do? Yes, you're going to put it in order from least to greatest. I did it earlier, so this wouldn't take me super long. I'll just write it right up here. Okay, 6, 6, 7, 7.5, 1, 2, 3, 4, 5 eighths, an 8.5, 4 nines, and then a 10. Okay, so now copy the set of axes below. Okay, so they want you to create this on your paper and then make a histogram for it. Now they've already kind of have it numbered and scaled. Let's see if I can make my computer a little bigger so I can see this. Yeah. So right here is the number of students, and then down here is the hours that they sleep, and this represents how many hours. So the smallest number is a 6, guys. So we're not even going to use the 1, 2, 3, 4, or 5. There are two numbers between a 6 and a 7. So find your 6 and 7, go up to 2, and then kind of color that in. Okay, between 7 and 8, there's 1, 2 numbers, because the 7.5 also is between a 7 and an 8, and it's a 2 as well, so it's going to be the same height. Now, between 8 and 9, 1, 2, 3, 4, 5, 6. So we're going to go all the way up to the 6 here. Between 9 and 10, 1, 2, 3, 4. And then between 10 and 11, there's just 1. Okay, there's your histogram. Number 60. Define a variable and then write and solve an equation for the problem below. Todd is 10 years older than Jamal. The sum of their ages is 64. How old are Todd and Jamal? Okay, we are going to define our variables right now. We are talking about Todd and Jamal. I'm very literal when it comes to these guys. It helps me to stay organized. You can do it however you want. I'm just going to show you my way of thinking. You might love it. It might inspire you to do it similarly, but you might have other ways. It's fine. But here's the deal. We're talking about Todd and Jamal. I'm going to write down exactly what I know about each. And we've done one of these before, guys. And however many variables we have, keep in mind, they're going to give us information for one of these, but really nothing for the other. If we were talking about 5 different variables, they would give us information for 4 of them, but not that 5th one. So don't panic when we're write down something for one of the brothers, but not the other, because you'll see how it works out. Okay, Todd is, I already know they're telling me something about Todd. So I'm literally, Todd is 10 years older than Jamal. So however old Jamal is, add 10, because Todd's 10 years older. Okay, and then all of a sudden it just skips Jamal and talks about the sum of their ages, right? So that's fine. All we know about Jamal is nothing. So J will represent what we know about him. The sum of their ages is 64. What does sum mean? That means to add, right? So if I add what I know about both of them, so here's my equation. This is what I know about Todd. It's no longer a T. We renamed him 10 plus J. Plus J for Jamal. It's that simple. If we added those together, it should be 64. So now you've got a problem you can solve. And look how great this works out, guys. We only have one type of variable in here, which means I can actually solve it. If I had a 10 plus j plus something about of t, I can't solve a problem if I have more than one variable in there. I can only solve for one variable at a time. So I've got 2j's plus 10 equals 64. Subtract 10 from both sides. Divide both sides by 2. Jamal is 27. Okay, so now, and it did say how old are Todd and Jamal. So we know how old Jamal is. Now we need to figure out how old Todd is. Well, we said whatever Jamal was, add 10, and that would be Todd. And if you really want to make sure you did it right, if you add them up, it should be 64. Well, you've got them. Add them up and see. Yep, that equals 64. Okay. Number 61. This is a checkpoint. That means by now they expect you really to be comfortable and familiar and competent with these kind of problems. So if you find that you're still really struggling with some of these, just try to get some extra help or put some extra time in. You can always ask your teacher. You can ask friends. Your parents can do this. But they really do mean by now you should be a proficient in this. So let these checkpoints help you, okay? So we've got negative 1/3 plus negative 3/8. And I've told you before, it's the same thing as saying this. Negative 1/3 minus 3/8. Okay? If your signs are the same, which they are, add the numbers and keep the sign. So we already know this is going to be a negative answer in the end. I'm just going to put this here. So now I'm not even worried about negative signs or whatever. I'm just going to add these two fractions. So 1/3 plus 3/8. I need a common denominator. 3 times 8 is 24. So 1 times 8 is 8. 8 times 3 is 24. 3 times 3 is 9. So that will be 17/24. Okay. B. Here's one of those situations, guys, where you have two negatives sitting right next door to each other, so it turns them both positive. So now we're just adding 2.6 and 1.5. I was really careful to line up my decimals, so now I can just do the addition, bring your decimal straight down. C, this is multiplication when they're in parentheses. And a negative times a negative is a positive. So now I don't need to worry about signs. I just know it's a positive number. I'm just going to multiply 4 1/5 times 1/3. Cannot multiply unless this is an improper fraction. So 5 times 4 is 20, plus 1 is 21. You can multiply straight across, or you can cross reduce. You're going to have to reduce in the end, no matter what. So I like to do it before so that I'm dealing with the smaller numbers. 21/5 can't be reduced. 1/3 can't be reduced. So now I'm going to start looking across. 1/5 can't be reduced, but look, 21/3 can. 21 divided by 3 is a 7. Okay, that's just a 1 now. 7 times 1 is 7. 5 times 1 is 5. So you can leave it 7/5 or you can turn it into 1 2/5. D, 2/3 divided by negative 1/2. Okay, so multiplication and division have the same rules when it comes to negative signs. So a positive divided by a negative is going to be a negative. I already know the answer is negative, so I'm just going to put that there. Now I'm not worried about it. I'm just going to do 2/3 divided by 1/2. Okay, here's keep, change, flip. Keep this one as is, change this to multiplication, and flip this over. So now it's 2/1. 2 times 2 is 4. 3 times 1 is 3. So you can keep it that way, or 1 1/3. Okay, E, negative 1 3/4 plus 5 1/3. Okay, if the signs are different, what are you going to do? I'm just going to let you think for a second. If the signs are different, find the difference between the numbers and bully gets the sign. So if you haven't noticed, I pretty much always determine if my answer is going to be positive or negative before I even solve the problem, because it's pretty easy to do. And then once you do, you don't even have to deal with negatives anymore. You just solve it. So find the difference between the numbers. So right now I already know I'm going to be subtracting them, but the bully gets the sign. Which number is bigger? 5. 5 1/3 is bigger than 1 3/4. He's positive, so my answer is going to be positive. So I'm not worried about it. But I did say I'm going to find the difference, so I'm going to subtract these. Okay, I need to get a common denominator. You don't even need to worry about the whole numbers, guys. You can just keep the fractions separate from them and just get your common denominator. 3 times 4 is 12, so 1 times 4 is 4. 4 times 3 is 12, so 3 times 3 is 9. Okay, so here's where, let me move this. I'm going to put my whole numbers back. So I'm going to need to do some rearranging with my whole numbers on this one, because watch, I can't subtract 4/12 minus 9/12. Well, I could, it'd be negative, but I have a whole number I can borrow. So check this out. I'm going to take one whole from that 5, and they'll have 4 wholes left, right? With that 1 that I took, I'm going to combine it with my 4/12. Watch this. I just need that 4/12 to kind of be a bigger, beefier number so that I can subtract a 9 from it. So I'm adding a 1, but wouldn't it make sense to add fractions? Don't you need common denominators? And if this one's already a 12, this one's going to have to be a 12. What would make this a 1 is if I put a 12 over a 12, right? Isn't that still the same thing as a 1? Okay, so when you combine them, now you have 16/12. Oh, that's going to be a lot easier. So let me erase this. And this is all messy. That was 16/12. So remember, we had 4 now. Now I can subtract 4 minus 1 is 3. Get your common denominator. And then 16 minus 9 is 7. Okay. Okay, F. We're dividing with decimals, so the rule with multiplying and dividing are the same. A negative divided by a negative is a positive, so I don't even have to deal with the signs anymore. I already know my answer is going to be positive. So I'm just doing 2.8 divided by 1.25. Can I do division if my divisor has a decimal? No. Turn it into a whole number, 2 hops to the right. But I can do that only if I come over here and make 2 hops to the right. Okay, so now I have 125 being divided into 280. Let me try to make this a little cleaner. Okay, so goes in twice. So it goes in 2 times, and out of 125, there's 50 left over. Now this can definitely be reduced. You can divide both of these by a 5. So that would be a 10. And how many times would 5 go into 125? Let me think for a second. 1, 5, 15. Ooh, that can still be reduced. We can divide them both by 5 again. Divide that by 5, and that's 2, and that's 3. So 2 2/3. Let me just make sure, guys. Hang on. Okay, it was actually 25, not 15. Glad I went back. But still, that can be reduced more. 10 divided by 5 is 2. 25 divided by 5 is 5. There we go. Okay. Was that the last one? Good job, guys. You made it through chapter 1. I will see you next time.